ನಮಸ್ತೆ ವಿದ್ಯಾರ್ಥಿಗಳೇ. ಸೊ ಈ ವಿಡಿಯೋದಲ್ಲಿ ಮೊದಲನೇ ಚಾಪ್ಟರ್ನ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಗಿರುವಂತಹ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಬಗ್ಗೆ ನಾವು ತಿಳಿದುಕೊಳ್ಳೋಣ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ನಾವು ಕಾನ್ಸೆಪ್ಟ್ ಹೋಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಅದರ ಮೀನಿಂಗನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಜನರಲಿ ಫ್ಲಕ್ಸ್ ಅಂತಂದರೆ ಏನು ಅಂತಂದರೆ, ಸೊ ದ ಮೀನಿಂಗ್ ಆಫ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಔಟ್ಫ್ಲೋ. ದಟ್ ಮೀನ್ಸ್ ಮೂವಿಂಗ್ ಔಟ್ ಅಂತ ಅರ್ಥ. ಓಕೆ, ಔಟ್ಫ್ಲೋ ಹೊರಗಡೆ ಹೋಗ್ತಕ್ಕಂಥ ಒಂದು ಕ್ವಾಂಟಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಪಾಸಿಂಗ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಇದೆಯಲ್ಲ, ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತಂದರೆ ಏನು ಅಂತ ಆಗುತ್ತೆ ಅಂದರೆ, ಸೊ ದ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಯರ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಮೀನ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಬಗ್ಗೆ ಹೇಳುತ್ತೆ. ಸೊ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಫ್ಲೋಯಿಂಗ್ ಔಟ್ ಆರ್ ಕ್ರಾಸಿಂಗ್ ದ ಗಿವನ್ ಸರ್ಫೇಸ್ ನಾರ್ಮಲಿ ಅಂತ ಅರ್ಥ. ನಾರ್ಮಲಿ ಮೀನ್ಸ್ ಇಯರ್ perpendicularly. Okay, so this is the general meaning of electric flux here. Electric flux means what? Electric field lines ಒಂದು ಸರ್ಫೇಸ್ ಇಂದ ಎಷ್ಟು ಔಟ್ಫ್ಲೋ ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದ್ದಾವೆ, ಒಂದು ಸರ್ಫೇಸ್, ಗಿವನ್ ಸರ್ಫೇಸ್. ಓಕೆ, ಒಂದು ಗಿವನ್ ಸರ್ಫೇಸ್. ಸೊ ಜನರಲ್ ಆಗಿ ಗಿವನ್ ಸರ್ಫೇಸ್ ಮೀನ್ಸ್ ಈ ಥರ ಒಂದು ಸರ್ಫೇಸ್ ಆಗಿರ್ಬೋದು, ಈ ಸರ್ಫೇಸ್ ಮೂಲಕ. ಸೊ ಯಾವುದೇ ಒಂದು ಸರ್ಫೇಸ್, ಗಿವನ್ ಸರ್ಫೇಸ್ ಮೂಲಕ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಷ್ಟು ಪಾಸ್ ಆಗ್ತವೆ ಅನ್ನೋದನ್ನೇ ಇದರ ಫ್ಲಕ್ಸ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ನ ಒಂದು ಮೀನಿಂಗ್. ಓಕೆ, ಸೊ ಬಟ್ ಹೌ ದೇ ಆರ್ ಪಾಸಿಂಗ್ ಹಿಯರ್? ಸೊ ದೇ ಶುಡ್ ಪಾಸ್ ನಾರ್ಮಲಿ ಹಿಯರ್. ನಾರ್ಮಲಿ ಮೀನ್ಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ಲಿ. ದಟ್ ಕ್ವಾಂಟಿಟಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಟುಡೇ. ಸೊ ನಾವು ಯಾವ ಥರ ಅಂತಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ನಾನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತೊಗೊತೀನಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಹಿಯರ್ a surface, given surface, and it is kept in a uniform electric field here. Uniform electric field. Okay, so some few lines are crossing normally here. So number of field lines crossing the given surface. This is the given surface here. Okay, so idu ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಕ್ರಾಸ್ ಆಗಿದ್ದಾವೆ ಅನ್ನೋದನ್ನೇ ನಾವು ಫ್ಲಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್. ಸೊ ದಟ್ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ನಾವು. ಹಾಗಾದರೆ ಸೊ ಡೆಫಿನಿಷನ್ ಏನು ಬರುತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂದರೆ, ದ ನಂಬರ್ ಆಫ್ electric field lines, number of electric field lines crossing per unit area normally. Crossing per unit area normally is known as a electric flux. Is called electric flux. Okay, so ಇದನ್ನು ನಾವು ಜನರಲ್ ಆಗಿ ಪೈ ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಕ್ರಾಸಿಂಗ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ ನಾರ್ಮಲಿ ಈಸ್ ಕಾಲ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ನಾವು. ಸೊ ಹಾಗಾದರೆ ಈ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಕ್ರಾಸಿಂಗ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ ನಾರ್ಮಲಿ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ? ಸೊ ಯಾವುದೇ ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನಿಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆ್ಯಂಡ್ ದಿಸ್ ಇಸ್ ಅನದರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವೇರ್ ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಮೋರ್ ಕ್ರೌಡೆಡ್ ಹಿಯರ್. And this is a stronger electric field and this is weak electric field. So now I will place here. So let us for time being you assume that so it is placed normally. The plane of the surface is normal to the electric field, direction of electric field. Okay, so I am placing here the same surface I am placing here. So here the number of field lines will be less and here the number of field lines will be more. That means here it depends upon the strength of the electric field. So where electric field is more stronger, the electric flux through a given surface will be more here. So it depends upon first quantity, electric field. And the second one here, I will consider the same electric field, but I am taking the same surface but the different orientation here. So let us consider this is the surface here. Let us take this stronger electric field here, little bit stronger. Okay, but now I am considering this. So the surface is placed like this here, normal, but it is making some angle now with the electric field. So that means here the electric flux will be less here. That means here it depends upon the angle between the area vector and electric field. Theta ಮೇಲೆ depend ಆಗುತ್ತೆ. And also it depends upon, you can see here the electric flux. So here the smaller area you consider, and you consider the larger area here. So the flux will be more here. The number of field lines passing through this surface, given surface, is more here. So that means it depends upon area of the surface. So three quantities ಮೇಲೆ ಇದು depend ಆಗಿರುತ್ತೆ. First one, it depends upon the electric field strength. Second one, it depends upon the area vector, and also third one, it depends upon the angle between these two quantity. Okay, so therefore electric field, electric flux is given by, so electric flux through a given surface is given by electric flux given surface is given by, there is a formula to calculate the electric flux, that is equals to E dot A. It depends upon electric field and area vector here. Okay, that means dot product of electric flux is the dot product of electric field and area vector. Or I can write this one as E dot product of the extension ಮಾಡ್ತಾ ಇದ್ದೀನಿ EA cos theta. So where, what is E? Electric field, A is area vector, and theta is angle between E and A, where E is electric field, vector A is area vector, and theta is angle between electric field E and area vector A. Okay, so this is the formula to calculate the electric flux. So remember, this is very important. So ಮುಂದೆ ನಾವು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಗಾಸ್ ಥಿಯರಮ್ ನಲ್ಲಿ ನೋಡಬೇಕಾದಾಗ, ಸೊ ಇದು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಗಿರುತ್ತೆ, ಫ್ಲಕ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೋಬೇಕಾಗುತ್ತೆ. ಸೊ ರಿಮೆಂಬರ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಸೊ ನಾವು ಇವಾಗ ಜನರಲ್ ಆಗಿ ನಾನಿಲ್ಲಿ ಒಂದು ಡಯಾಗ್ರಾಮ್ನ ಹಾಕ್ತೀನಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ನ ಯಾವ ರೀತಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋದಂತ. This indicates here electric field. This is the uniform electric field. These are electric field lines. Okay, these are electric field lines. E is the electric field here. So now we consider a surface here, I will consider a given surface. Okay, and this is the area vector. Area vector is always normal to the surface. This is area vector A, and this is electric field E, and this is the angle between area vector and electric field. So this gives you the electric flux. Okay, and the E on the surface ಮೂಲಕ ಎಷ್ಟು field lines pass ಆಗ್ತವೆ ಅನ್ನೋದೇ electric flux. So here one thing you need to know that is very important here about the direction of area vector here. Area vector direction ಯಾವ ತರ ತಗೋಬೇಕು? As I already told you, the direction of area vector is always normal to the surface. It is always normal to the surface. So ಇಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ನೀವು ಸರ್ಫೇಸ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ, ಆ ಒಂದು ಸರ್ಫೇಸ್ಗೆ ಯಾವಾಗಲೂ ಏರಿಯಾ ವೆಕ್ಟರ್ ಏನಾಗಿರುತ್ತೆ ಅಂದರೆ ನಾರ್ಮಲ್ ಆಗಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್ we consider this is the surface now, and the area vector will be like this, normal to this. Look at here, normal means perpendicular ಆಗಿರುತ್ತೆ, ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಈ ತರ. Okay, so for this surface the area vector will be like this, direction of area vector. For this it is perpendicular like this. Okay, so suppose if this is like this, the area vector is like this, and here the direction of area vector is here in this direction. Okay, it is always ಈ ಸರ್ಫೇಸ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತೆ, ಈ ಸರ್ಫೇಸ್ಗೆ ಇಲ್ಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, so now we will see this concept with some demonstration. So these lines indicates the direction of electric field. These are electric field lines, and this is the surface, given surface here. Okay, so you can see the surface here. Okay, so and this indicates here it's normal to this surface. This indicates here the direction of area vector here. So now you can observe here, initially I will consider the situation where there are no field lines here, that is number of field lines crossing the surface is 0. I will consider first that situation. I will consider here. So now this is the surface here, this is the surface, these are the field lines you consider here. So there are no field lines crossing this. ಇದರ ಮೂಲಕ ಅಂದ್ರೆ ಈ ಸರ್ಫೇಸ್ ಮೂಲಕ ಕ್ರಾಸ್ ಆಗ್ತಕ್ಕಂಥ ಯಾವುದೇ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಲ್ಲ. and you observe the angle between the electric field and the area vector here. The area vector is, as I already told you, it is always normal to it. This is the area vector direction. So each surface is normal ಆಗಿರುತ್ತೆ. You can see here this is normal. So ಇವಾಗ what is the angle between the area vector and the electric field? 90 degree here. But the plane is parallel ಆಗಿದೆ. Plane is parallel to the electric field, but the area vector is perpendicular to the electric field. So the angle is 90 degree here. So number of field lines idra ಮೂಲಕ pass ಆಗೋದು 0 ಇದೆ ಇವಾಗ. So now the electric flux is 0 here. So when the angle is 90 degree, according to the formula we had here, cos 90 becomes 0. So electric flux will be 0 here. So that means here when the angle between the area vector and the electric field becomes 90 degree, then the electric flux becomes 0 here. Okay, so now you consider this. Now I will just change the angle here, because if you change the angle here, look at the angle is now changing here. So now few field lines are crossing this area, this surface. Okay, So few field lines are crossing. And now if the angle increases angle decreases, and now the number of field lines will be more, and here, so you can see as the number of field lines crossing the given surface is increasing, and when the angle becomes 0, so when that is the electric field is it is now parallel to the area vector. So in this case the angle is 0. Now the number of field lines crossing this given surface will be maximum here. So therefore I will get here maximum flux here. So that is possible when the angle is 0 degree. So therefore if theta is equals to, first of all we discuss about the minimum flux here, that is theta is equals to 0. So then the flux or the electric flux passing through a given surface is 0 or minimum. Because here, so we have the flux formula, pi is equals to E A cos theta, and here theta becomes 90 degree, that is E into A into cos 90. What is the value of cos 90? Cos 90 value is 0. So therefore flux becomes 0. So in this case it is a minimum flux I will get here. Okay. So now if the angle between the area vector and the electric field is 0 degree, then electric flux passing through the given surface is maximum ಆಗಿರುತ್ತೆ. In this case it is maximum. ನಾನು ಆಲ್ರೆಡಿ ತೋರಿಸಿದ್ದೀನಿ ಆ್ಯಂಗಲ್ 0 ಇತ್ತು ಅಂತಂದರೆ, ಸೊ ಅಂದರೆ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿಗೆ ಸೊ ಈ ರೀತಿಯಾಗಿರುತ್ತೆ. Look at here. So the electric field and the area vector both are parallel ಆಗಿದ್ದಾವೆ. So that is angle is 0. So if the angle is 0, so now what happens? There are maximum number of field lines passing through this. ನೋಡಿ, ಸಾಕಷ್ಟು maximum number of field lines ಇರುತ್ತೆ, ಹಾಗಾಗಿ ಫ್ಲಕ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿರುತ್ತೆ. That is, I can say here EA cos theta is the formula. EA cos 0 degree, that is equals to E into A. Cos 0 is 1. So this is the maximum flux. Okay. So it is maximum when theta is 0 degree. If it is minimum when theta is 90 degree. And now what about type of quantity here? Is it a scalar quantity or it is a vector quantity? So electric flux is a scalar quantity because it just gives the number. It is a number, so numerical value it is a. Therefore it has no direction, and also you can see from the previous discussion it is the dot product. So dot product of any two vectors results a scalar quantity. So therefore flux is a electric flux is a scalar quantity. It is a scalar quantity. Okay. So now what about the SI unit of electric flux? electric flux is. So we have the formula. From the formula I will tell you what is SI unit, that is EA cos theta. E means electric field, the SI unit is Newton per Coulomb. Area is SI unit is meter square, and cos theta has no unit, so SI unit is a Newton meter square per Coulomb. This is one, or one more is there. So using the same formula here, so I can write E as E is one more unit for electric field is Newton volt per meter. Okay, so area is meter square, cos theta has no unit, so you will get here volt meter. So these are the SI units of electric flux. This is about the brief introduction about the electric flux. Thank you.